So I decided to choose problem 7, chapter 7, problem 55. Chapter 7, problem 55. And so the problem starts with a man throwing a baseball. And so I'm gonna represent this as here's the drawing. The baseball thrown at an initial velocity of 40 meters per second with an angle of 30 degrees above the horizontal. And so the problem has x and y components. The x component is adjacent to the angle, which means that the x component would be 40 cosine 30, while the y component would be 40 sine 30. And we need to find the x and y components of its initial speed because it's thrown at an angle. So next week we have to draw the trajectory of the baseball. So which means if the baseball is thrown, will the x component change or not? So when throwing the baseball, the x component, as it reaches its peak, it won't change, it will stay the same. But so as the baseball moves forward, as it reaches its max height, the x component of its velocity will remain 40 cosine 30. 40 cosine 30. However, the y component will shrink while the baseball reaches its max height. So the y component will eventually disappear. So for example, here's the y. As it reaches its peak, it will shrink until it disappears. And so when we calculate the kinetic energy, we're gonna have no y component. It will be 0. And so the kinetic energy would be half mv squared. We have the mass, which is 0.15, and the velocity will be only 40 cosine 30, and this should be all squared, which gives us 90 joules. So for chapter 8, I chose to do problem 38. And then the problem says, what is the average power of the elevator motor during this time interval? And then for average power, we know that average power is equals to the force times the average velocity. And then it's important to know that since the equation is asking for the average power of the elevator motor, then when it comes to plugging force, we have to use the force the elevator is exerting. And so we start by doing a free body diagram. Here's FG equals mg. And we have the force going upward, which we can call Fm. And since it's going upward, we can put a positive sign, and here's a negative sign since it's going downward. And then according to Newton's second law, we can say that F net is equal to mass times the acceleration. And then the F net, we have the Fm, which we stated earlier, minus the mg, which equals to ma. And then we can move this mg. Fm equals ma plus mg. Since we have two m's here, we can factor the m. So Fm equals m times a plus g. We have the mass. So first we have the mass, we have the gravity, but we don't have the acceleration. And then for acceleration, we know that it's the final minus the initial divided by time. And then the acceleration is change in velocity over time. So our final is 1.75, and since it's starting from rest, so our initial is 0 over 3, which is the time interval. And we calculate this and we get 0.583 meters per second squared. Plugging it into this formula, the mass is 650 times 0.583 plus the 9.8, which we get 6.75 times 10 cubed newtons. This is the force the motor is exerting on the elevator. And so we have the power equals the force, 6.75 times 10 cubed. Now we have to get the velocity, and then to get the average velocity, we're gonna have to add the final plus the initial divided by 2. Since the initial is 0, so we're just gonna have to divide 1.75 by 2, and we calculating this, we're gonna get 0.875 meters per second. and this would give us so 6.75 times this would give us 5.91 times 10 cubed watts. And if we want to convert this to horsepower, then we just gonna multiply this by 1 horsepower, and according to the book 1 horsepower is equal to 746 watts, and this would give us 7.9 horsepower, or 5.91 times 10 cubed watts. So this is for A. Doing B, solving B, they want to know so since they want to know the constant speed, so at a constant speed the acceleration has to be is 0 meters per second squared, and according to Newton's second law, force net is equal to ma. And then we're gonna repeat the same process. Sorry, my phone almost ran out. So Fm minus mg, which equals to ma, then Fm minus mg, and since our acceleration is 0, so we're gonna have 0 here, and then we're gonna move this to the other side. Fm equals mg, then so this is Fm, so we're just gonna have the force as mg. Average power is equal to mg times the the velocity, average velocity. And since they want to know the average velocity, and since it's at a constant speed, so we're gonna have constant speed, so 1.75 being the final velocity, so 1.75 has to be the initial velocity, so 1.75 plus 1.75 divided by 2 would give us 1.75 as well. So the mass, which is 650 times 9.8 times, as we said, 1.75, and this would give us 1.11 times 10 to the power of 4 watts. And if you want to convert this to horsepower, just multiply this by 1 over 746, and this would give us 14.9 horsepower. Again, sorry for the camera and the mess because I'm moving out. So for chapter 9.2, I decided to choose problem 6. And for problem 6, there's two problems. There's two parts, part A and part B. First, I'm gonna do part B, then part A, because part B gives us the answer for part A. So we're gonna start by saying that the velocity of the girl relative to the ice is equal to VGI, and then since it's a relative velocity, then VGI would equal to VGP, V sub GP plus V sub PI, and we can let the velocity of the girl relative to the ice equals the velocity of the girl relative to the plank, and the velocity of the plank relative to the ice. And notice that the question gives us VGP, which is the girl, as the girl begins walking at a constant velocity of 1.5 meters per second. So this would be 1.5. And next we're going to use the conservation of momentum, which is relative to the ice, by saying that 0 would equal to mg VGI plus mp VPI. Notice that 0 is the initial momentum. There's no momentum at first, and then mg VGI would be the final momentum of the girl, and mp VPI would be the final momentum of the plank. Then we're gonna solve for VPI. We're gonna divide this and move this here, so VPI would equal to negative mg VGI over mp, and then we're gonna substitute the equation for the earlier one, which is here. So this would be VGI equals negative 1.5 minus mg VGI over mp, and then we're gonna factor, and so VGI times 1 plus mg over mp would equal to 1.5. So we're gonna move this here, and then VGI equals to 1.5 over 1 plus mg over mp. So we're gonna divide, and then we're gonna compute this formula and get 1.15 meters per second. So this is the answer for part B, which is which is the girl's velocity relative to the ice surface. And then I said we did part B then part A because part B would give us the answer for part A, which is the same equation, VGI equals VGP plus VPI. So for this, he wants us to find VPI. So we had VGI, which is 1.15 equals 1.5 plus VPI. So the answer would be VPI equals negative 0.345 meters per second. And the reason it is negative, because this means that it is sliding to the left as the girl is moving to the right. Yeah. Chapter 10, I chose to do problem 9 from chapter 10. Problem 9 says that I need to find the angular acceleration of this drill as well as the angle of rotation. And the drill starts from rest. So the initial angular velocity is 0. So expressed as omega 1 is 0. And then notation for the initial angular velocity, this is, and the final angular velocity of this drill is given to us with the value of 2.9 times 10 to the power of 4 revolution per minute. So this is required to change. So in the question they want it to be as they want the answer to be as radiant per second. So 2.9 times 10 to the power of 4 revolution per minute. So this we change it into radians per second by multiplying the revolution by 2 pi, and then dividing the minute by 60 seconds. And then computing this would give us 3036.87 radians per second. And then in the question they want us to find the angular acceleration of the drill. And so to find the angular acceleration, we should convert the omega 2 should be converted to radians per second, which we already did because the angular acceleration required in radians per second. So we have a rotation motion problem. So we have a kinematic equation for rotational motion. We have 4 equations which apply for constant acceleration motion, as we have in our problem, but we will use only two of these equations. And then in general, the kinematic of rotational motion describe the revolution between the time, the angular velocity, and the acceleration, and the rotational angle. So we will use the equation for the angular acceleration, which is alpha is equal to the change in velocity over time. So the change in velocity, which will be omega 2 minus omega 1 over the time. And omega 2 is the final angular velocity minus the initial angular velocity over the time to reach final velocity. So this will give us some, so we have the omega 2, which is 3036.87, and omega 1 is 0, so this is only just minus 0 over the time. The time is 3.2 seconds as given, so this would give us 949 radians per second squared, per second squared, yeah. So for B, the second equation represents the angle of rotation. So we need so we have theta. So we're gonna have theta, which equals to the omega 2 times the time. Omega 2 is the initial initial velocity times time plus omega 1 times time plus half times the angular acceleration times the time squared. So this would be 0 because omega 1 is 0. So theta would equal to half times the 949 we just got first, times the time, which is 3.2 seconds squared. This would give us 4,858.88 radians. So I chose to do problem 22 from chapter 11. And first of all, I'm gonna draw a sphere for the problem. And then this sphere is 15 kilogram, mass is 15 kilogram, and has a radius of 0.5 meters. And its angular speed is 3 radians per second. So, so they want us to calculate the angular momentum, while the moment of inertia of solid sphere is I, which I would equal to 2 over 5 mr squared times 3. So 2 over 5 times the mass, which is 15, times the radius, which is 0.5, squared times 3. So calculating this would give us 1.5 kilogram meter squared. And then the formula for the angular momentum is, so angular momentum is L equals IW, and then I is 1.5, and then omega is 3. Omega is 3. So angular momentum is 4.5 kilogram meter squared per second